Hello, in this lecture we will find the radius of a circle. In the drawing we have a circle. Inside the circle we have a square in the red color, and the center of the circle is at point O, and this size is 6 units and this size is 3 units, and actually we will name this point point M, or we will define this point as point M. So actually line segment MC equals to 6 units, and we will name this point point N. Okay, so line segment AN equals to 3 units, and we want to find out the radius of this circle. Okay, let's define line segment OM as Y. Okay, OM equals to Y according to our definition. Line segment OM equals to Y. Okay, line segment OM equals to Y. OM equals to Y, and let's define line segment ON as X. Okay, line segment ON equals to X. According to our definition, line segment ON equals to X. Okay, line segment ON equals to X. Actually, line segment OA is the radius of this circle, because O is the center of this circle, so OA is the radius of the circle, and also OC is also the radius of this circle. Okay, so our first question is that OA equals to OC, both of them radiuses of this circle. Okay, OA equals to OC. OA equals to OC because of the fact that both OA and OC are the radiuses of this circle. But as you can see from the drawing, OA equals to X plus 3. So we can write in the first equation that OA equals to X plus 3, and OC equals to Y plus 6. Okay, OC equals to Y plus 6. Again, the first equation, we know that OA equals to x plus 3. OA equals to x plus 3. Okay, and OC equals to y plus 6. OC equals to y plus 6. Okay, so we actually can subtract 6 from equation number 1. We will get that x or y equals to x minus 3. Actually, x plus 3 minus 6 equals to x minus 3, because 3 minus 6 equals to minus 3, so in total we have x plus 3 minus 6 equals to x minus 3, and y plus 6 minus 6 equals to y. So y equals to x minus 3. Okay, that is our first equation. Y equals to x minus 3. And actually, because of the fact that this is a square, so if this side of the square equals to y, then this side also equals to y, because all the sides in a square are equal to each other. So also bn equals to y, because of the fact that all the sides in a square equals to each other. So OM equals to y, so BN also must equal to y. But we know from our first equation that y equals to x minus 3, y equals to x minus 3. Okay, and actually OA equals to OB. Why? Because both of them are radiuses of this circle. Okay, OA, line segment OA equals to line segment OB, because both of them are the radiuses of this circle. OA equals to OB. OA equals to OB. But OA equals to x plus 3. And OB equals to OA. So OB, that is the radius of this circle, also equals to OA, that is also the radius of this circle. So OB also will be equal to x plus 3. Okay? Because of the fact that OA and OB are both the radiuses of this circle, and OA equals to x plus 3, so OB, that is also the radius of this circle, also equals to x plus 3. Okay, so now we can implement the Pythagorean theorem in the right green triangle. Okay, so in the right green triangle, O and B, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, OB square, the square of the hypotenuse, this is OB square. This is our second equation, OB square equals to the sum of the squares of the perpendiculars equals to ON square plus BN square. Okay, so actually OB square is the square of the hypotenuse in the right triangle, green right triangle OBN. The square of the hypotenuse OB square equals to the sum of the squares of the perpendiculars equals to ON square plus BN square equals to ON square plus BN square. But we know that OB equals to x plus 3, ON equals to x, and BN equals to x minus 3, equals to y that equals to y minus 3. So we can substitute OB by x plus 3, we can substitute ON by x, and we can substitute BN by x minus 3. So we will get that x plus 3 square equals to ON square is x squared plus x minus 3 squared. Okay, again we substituted Bn by x minus 3, we substituted, okay, Bn by x minus 3, we substituted On by x, and we substituted BO by x plus 3. BO, the hypotenuse of this right triangle, we substituted by x plus 3. Okay, so in the second equation, we will open the brackets in the second equation. Okay, we opened the brackets in both sides of equation number 2. X plus 3 square equals to x square plus 9 plus 6x according to the formula that a plus b square equals to a square plus b square plus 2 times ab. Okay, and x minus 3 square equals to x squared plus 9 minus 6. Actually, we have x in this side of the equation and x in this side of the equation, so x squared is cancelled. So we have 9 in this side of the equation and 9 in this side of the equation, so 9 is also cancelled. So we left only with the second equation. We left with 6x that equals to x squared minus 6x. Okay, what is left after we cancelled the x and square 9 is 6x in this side of the equation, and here we left with only x squared minus 6x. Now we will subtract 6x from the second equation. So we subtracted 6x from this second equation. 6x minus 6x equals to 0, and x square minus 6x minus 6x equals to minus 12x. Okay. Again, 6x minus 6x equals to 0, and x squared minus 6x minus 6x equals to x squared minus 12x, because minus 6x minus 6x equals to minus 12x. Okay. In the next step, we will take a common factor x out of equation number 2. Again, we will take a common factor x out of equation number 2. We will get that so we took a common factor, we took a common factor out of equation number 2. We got that 0 equals to x times x minus 12. So we have two solutions to this equation. Either x will be equal to 0, or x minus 12 will be equal to 0. X equals to 0, it is impossible, because we are talking about the size of the, if the size of the side of the square is 0, so it doesn't exist, so it is impossible. So the only solution that is left, that x minus 12 equals to 0. X minus 12 equals to 0, so here x equals to 12 units. Okay, x equals to 12 units, and actually the radius of this circle is x plus 3, so the radius equals to x plus 3, and x equals to 12, so it is actually 12 plus 3, so the radius of this circle equals to 15 units. Okay, so the final answer to the question is that the radius of this circle is actually 15 units. Okay, now I will summarize the lecture. I actually wanted to find out the radius of this circle. In the first step, we defined this point as M and this point as M. We defined line segment OM as Y and line segment ON as X. And line segment MC equals to 6 units, and line segment AN equals to 3 units. Actually, we know that OA equals to OC, because both of them are the radiuses of the circle, because point O is the center of the circle. So we have equation number 1 that states that OA equals to OC. Again, OA equals to OC because both of them are radiuses of the circle. But OA equals to Y plus 6, and OA equals to X plus 3, and OC equals to Y plus 6. So we can substitute OA by X plus 3, and we can substitute OC by Y plus 6. Okay, so we got that x plus 3 equals to y plus 6. So here we substituted 6 from this equation. We got that y plus 6 minus 6 equals to y, and x plus 3 minus 6 equals to x minus 3. So we got the equation number 1 that states that y equals to x minus 3. Okay? Actually, OA equals to OB because both of them radiuses of this circle, but we know that OA equals to x plus 3, so OB that equals to OA also will be equal to x plus 3 because both of them radiuses of this circle, and this is a square, so if one side of the square equals to y, and so the other side must be equal also to y because all the sides of a square are equal to each other. So if this side of the square equals to y, then the other side also will be equal to y. But according to equation number 1, y equals to x minus 3. So we can write here that y equals to x minus 3. So in the right triangle, green triangle O and B, we know that one side equals to x, and the other side equals to x minus 3, and the hypotenuse, that is also the radius of this circle, equals to x plus 3, so we can implement the Pythagorean theorem in order to find out the value of x. The Pythagorean theorem states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Okay, so OB square will be equal to OA square plus OB square will be equal to ON square plus NB square in the right triangle ONB. Okay, OB square will be equal to ON square plus NB square. But we know that OB equals to x plus 3, ON equals to x, and Bn equals to x minus 3. So we can put the data inside equation number 2. And we solved equation number 2 and we got to the final answer that x equals to 12 units. Okay, but the radius of the circle equals to x plus 3. So the radius of this circle will be equal to x, that is 12 units, plus 3. That is to say 12 plus 3, that is 15 units. So the radius of this circle equals to 15 units. Okay, thank you very much.